everyone, and welcome back to part 3 of this series. This is going to be the final part of the vertical projectile motion series. Now, in this instance, we're going to look at what's going to happen and how the object would behave if a ball is dropped, bounces, and then it drops to the ground again. Now, in this instance, I'm going to take my upwards direction as positive. What we see over here is that we've got our position time graph, velocity time graph, and acceleration time graph over here. And then this drawing I have over here is just a diagram that just demonstrates how the object would move as the ball is thrown down, hits a point, bounces back up again, then goes back down. So the point where it reaches the contact with the box is when it would hit the box, go back up, and then go back down again. Now, if we look at the position time graph, we see that the ball was dropped at point A. So the initial velocity it had was 0 because it was dropped at this point. The ball will bounce at B, go back up at C, C will be its maximum height, and then it will go back down again, which is below its reference position. So this is B is the reference position, C is the maximum height. And if you think about it theoretically, you can actually see this happening. If you were to throw an object, a ball or any object down, it would hit the first point of surface, bounce back up again, and then fall back down. So then this is how the graph would behave, kind of like a double parabola. In this case, this is point A. Our initial velocity is 0. Hits point B, which is the surface, goes back up to C, which is its maximum height, and then goes back down again to point D, and this is going to be the final velocity of the ball as it hits the ground. Now, if we look at the velocity time graph, the same thing happens just like in part 2. The velocity increases in the downward position. The ball would go down, it would spend a split second in contact with the surface, in this case the box. It goes back up again before it bounces back up, and as it goes back up in that split second, the velocity will also increase at position C, as we see over here, and then it descends downwards to position D. This would be the final velocity of the ball. So as it goes up, the ball increases in the downward position. The reason why we also took upwards as positive, because this also shows us that everything below the t-axis is negative now. So the ball is at point A, it increases as it goes up, hence in the downward position. Then that split second, when it reaches contact with the box, it would go back up again before it bounces back up, which is point C, and then point C is the maximum height, then it would go down till point D. Now, if we look at the acceleration time graph, we see that during contact with the block, the ball will accelerate upwards, and then it will become positive. So this is the 9.8 meters per second acceleration. This part over here represents the split second when it's in contact with the box and when it bounces back up and bounces back down again, and then as it descends to the ground, this is what we would call the negative acceleration because the ball is going down again. Now, I hope you guys have enjoyed this video. I hope to see you in my next video, which I'll be posting very soon. Please like, comment, subscribe, and share, and I'll see you guys in the next video. And if you guys have any questions, you're more than welcome to leave them in the comments, and I'll most definitely get back to you. Bye everyone, and have a lovely day.